Welcome to FEA Journeys, an FEA Academy podcast dedicated to sharing the experiences of seasoned engineers who have achieved success through finite element analysis. In this podcast, we will focus on highlighting the personal stories and the professional path within the FEA domain, catering to both aspiring and experienced engineers interested in exploring practical applications and achievements in FEA. In this podcast, you're going to hear individuals from different sectors of the FEA industry, including FEA software company, FEA consultant, companies that design their own products using FEA, and companies offering engineering services. These interviews will showcase diverse backgrounds and career journeys within the FEA field. For this episode of FEA Journeys, we speak with Steffan Evans. Steff is a doctor of engineering in multi-parameter structural optimization. He spent 20 years in Airbus BAE Systems supply chain, involved in strategic FEA development, analysis, and verification. Now he's running Evotech CAE, an engineering product consultancy company in CAE, FEA, and design optimization, partnered with Hexagon for training and technical resales. And you probably know Steff as the Apex guy on LinkedIn. Thank you very much, Steff, for joining us on this new episode of FEA Journey, an FEA Mastery podcast. And today we're going to discuss together about your journey in the FEA industry. So let's start.
Good. Thank you. It's great to be here. Thank you for having me on the podcast.
Thank you to you. Thank you to you. So let's start today this interview. I just want to start very quickly with a presentation. Could you share with us a bit about your background and how you first got involved with finite element analysis? I mean, what sparked your interest in this field and led you to where you are now?
Yeah, certainly, Dominic. Thank you. Okay, so yeah, that's a big question, and I'll try and keep it a relatively short answer. But I think probably the starting point for me was when I was a teenager. And you know yourself, and I don't know if people watching know, but I have a very big interest in BMX as a sport bicycle. So I've ridden BMX bikes all my life. And one of the things that I sort of first got involved with was when we were riding the bikes and doing tricks and doing jumps and things, the bikes would break quite often. Okay. We would see, cracks appearing at welds and frames bending and wheels bending, and all this kind of stuff. And it got me interested in the concept of how a structure works quite early on. So that was, perhaps if you pause that in the mind, in terms of my understanding. And then obviously in school, so I was interested in maths and physics and science. In fact, my father was a design technology teacher at the school that I went to. Okay. So very interesting.
He was your teacher?
He was my teacher.
Yeah. Oh, really? That's good.
Yeah. When we took the General Certificate of Secondary Education, GCSE, that we call it in the UK. So 16 years old. My dad was my teacher for two subjects. So for design technology and for graphics, which was drawing as well. Okay.
Yeah.
So he was my teacher. But my interest in design technology and drawing and maths and physics led me down a road into engineering.
Okay.
So university, I studied mechanical engineering, and I can remember vividly one day going into first year graduate program, going into one of the CAD technology laboratories and seeing a poster on the wall, and it was for ANSYS, FEA software product. And there were structures on the poster. There may have been a bicycle, an aircraft, a car, whatever. And I could see these coloured plots. I didn't know what it meant.
Yeah.
But I remember talking to somebody and they were saying, well, this software can be used to predict how a structure is going to work. And I was like, whoa, that is magic. That is magic.
Yeah.
And
That's really science fiction.
yeah. And bear in mind, so I'm in my early 50s now. So this was in the early 90s when this was coming about. So we hadn't really used computers. I didn't really use computers at school.
Yeah.
We're into a university environment, so we have these CAD terminals and this software. And I thought, wow, I understand. Well, I'm interested in understanding why my bicycle is breaking. Here is a software that can show me what's going on, and I thought, wow, that's incredible. So through my studies, we took classes in basic mechanics, basic structural design, CAD design, and then additional classes in finite element analysis. And my industrial project was with a bicycle company, a company called Raleigh, who are very well known in the UK and potentially globally as well. And I looked at using FEA software to predict how a bicycle would work. In fact, the one bicycle that we were looking at had a very specific vibration problem. It was an instability. So I used ANSYS and some of the CAD tools that we had to model this problem and try and understand what the structure was doing. And we very, very fundamental, and looking back, very, very straightforward and basic. But for me at the time, it blew my mind. It was crazy that we could model this stuff. So yeah, that was the introduction into my academic stuff, and then obviously I then did quite well at university. Took a postgraduate qualification, so looking at PhD level research. Again, very heavily influenced in terms of FEA. I was looking at optimization, structural optimization, and interestingly, some very early AI applications. So looking at things like neural networks and genetic algorithms to try and optimize a structure. And then from that went on into industry, and like lots of people involved in FEA, ended up in the aerospace industry. And like yourself, developed my skills and my understanding through learning and practical application, developing various models and understanding for aircraft structures. So worked on lots and lots of different structures over the years, up to, well, probably I think over 25 years of work in the aerospace and related industries, up to now where I'm now running my own consultancy, Evotech. And I get to work on lots of interesting problems with FEA across the board, so yeah, that's my story.
Really cool, really cool. No, that's very interesting. First, it's fun to know that your dad was your teacher. I love it.
Yeah.
But it's good to know also that finally you were interested by FEA due to one of your patients. Okay, it's a BMX patient. So that's really cool that to know that finally you meet the two your patient for BMX and FEA together. Very, very good.
Yeah, I mean, I going full circle. Now I'm in a consultancy role. I work with lots of companies on lots of different projects.
Yeah,
I have done a lot of work in two-wheel, bicycle and motorcycle structural development. So I mean, I'm sure we'll talk about this in a bit more detail, but some of the projects which I find really interesting. Where we can make a real change in something.
Well, I understand what you mean. My passion is in aircraft, and I am doing a FEA on aerospace products. So I understand really that. Sure. So now I would like to talk with you about the early challenges. We'd like to know what were some of the initial difficulties you faced when you first began working with finite element analysis. And
Yeah.
how did you navigate the obstacles to build your expertise?
Okay. Yeah. That again. That's a big question. I think one of the difficulties and roadblocks that many people come up against in a university environment is that the academic teaching can be very theoretical, very mathematical,
So true.
and it can often be difficult to transition that mathematical knowledge into practical application. So I
Absolutely.
mean, many years ago, people would use finite element analysis with a pen and paper. They would
Yes.
solve truss and beam type problems using those sort of fundamental mathematical techniques. But in the modern era, FEA is wrapped up in very much into a software
Correct.
environment,
Correct.
and it's very easy to people can use the software without really knowing what's going on in the background,
Mm.
So from an obstacle perspective, or for sort of difficulties that I certainly came up against was professors and teachers who knew the mathematics, knew the theory very well, but perhaps didn't know how to transition that knowledge into working software,
Yeah.
working practical application
Yeah.
to allow
Yeah.
me to solve real problems,
Yeah.
And it did take me a lot of time to try and bring those two areas of knowledge together
Yes.
to join the dots. I mean,
Yeah.
one of my, again, not wishing to jump ahead too much, but one of my very first jobs was working with MSC Software
Mm-hmm.
in their technical support team. So dealing with software application, helping companies or individuals use the tools. And that really was what I would call an apprenticeship in bringing those two things together. So
Yeah.
having the theoretical knowledge, but
Mm-hmm.
how is that really worked through in the software environment,
Yeah. Yeah. Yeah.
to become a good practicing FEA engineer.
Absolutely. Yeah. 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 Very interesting, Steph. Thank you for sharing this point. And I think this bridge between the theoretical aspect of FEA and the practical aspect, how FEA is used in the industry, this bridge, there is still a lot of work to do by universities because I'm pretty sure you have the same observations when we are working with new people, new graduates from universities. It's obvious that they don't know how to apply. They know how it works in the background, but they don't know. They are struggling to apply it practically on real projects. And it's a yeah, it's a big challenge. I think this challenge will be there for a long time because I don't see universities creating this bridge efficiently.
Hmm. Yeah, I mean, there are some, there is some work going on. I'm heavily involved
Yes,
with some of the
yes,
academic support team with Hexagon, the company I'm partnered
yeah,
with, who are trying to address this issue where
absolutely, absolutely.
they try and bring the two areas together.
Yeah, yeah.
But
You're right. You're right. Yeah, yeah. It's important to mention that because many efforts is done, but it's not enough. So far, my opinion is that it's not enough. We need to do more, and you do it, I do it. More people are doing it, but it's absolutely needed to help people who want to do a career in FEA.
yeah,
So it leads me to the other question around the problem solving with FEA. It's related to the previous question, but as you said, we were using FEA to solve complex engineering problems. We don't use FEA to solve simple problems. We use FEA to solve complex problems. Can you describe a specific project where FEA a project where FEA played a crucial role in addressing a particular challenge engineering that you encountered in your career?
Yeah. Okay. So I mentioned my work in the aerospace industry, and
Mhm.
obviously developing a commercial or military aircraft
Okay,
is a long process.
sure.
So the initial design, initial conceptual work is in some cases many years ahead of a physical structure becoming available. And
Mhm.
obviously because FEA, the nature of the analysis that we do, we are developing that structure computationally or digitally
Mhm. Mhm.
before the physical part is available. So there's many examples that I could draw on from my aerospace background, if you like. But
Yeah.
perhaps the ones that I find most satisfying, the projects that I find most satisfying, are the ones where it's a much quicker turnaround. So we have a company, and again, I've worked with many companies through my consultancy, lots of short projects, maybe 1 week, 1 month, 6 months, or whatever. But
Mhm.
they need the analysis capability to say, okay, we have a design. Maybe the design doesn't work. Maybe we've had a failure during operation,
Mhm.
but we need to have a better understanding of what that structure is really doing,
Yeah.
so we don't waste money on production, we don't waste money on tooling, this kind of thing. We want to try and get it as optimal as possible,
Yeah.
as we can. So again, I mentioned some of the two wheel projects that I've looked at, bicycle, motorcycle development, where we could maybe have a problem on a Monday, analysis, 2 or 3 days worth of analysis to get
Mhm.
to a solution, and that solution then goes into manufacture at the end of the week.
Yeah.
So those are the types of projects that I find perhaps more satisfying
Yeah.
than the very long time frame, long lead time work that you might see in an aerospace, commercial or military program. So
Okay.
lots of examples where those things are very important, but it's certainly the shorter time frame problems that I find most satisfying, I think.
Yeah, very instructive for the audience. This example, Steph. Thank you for that. So for those who are new to FEA and looking to dive into the field of FEA, what advice would you offer? Are there any particular steps or resources you would recommend to help them get started efficiently,
Mm,
or any other advices
mm.
you would
Yeah,
share?
yeah, okay. So for people who've maybe been through university studies, and they're about to embark on a career, and they want to develop their skills as a FE analyst, or structural designer, whatever you want to call it. I'd probably advise people to look for companies where you will get a good foundation in using FEA within your daily job. That I think
Yeah,
that's pretty important. So lots of companies will have FEA departments. The bigger companies will have dedicated departments. Certainly in an aerospace environment, whether they are FEA or structures or stress engineering departments,
yeah,
or some of the smaller companies where you might learn FEA on the job with lots of other skills that you might need to be a proficient engineer. So
yeah,
so look for companies that have this foundation, these skills already built in, so you can learn from other people.
oh
Peer
yeah,
learning is really important. I think
so true. Oh
in
yeah,
in in what we do.
yeah,
Start simple. So don't go diving in for the latest and greatest multi-physics problem.
yeah, yeah. I
If
like
if
that one.
if if you want to model a pencil under load, then
Hmm?
model a pencil under load and be able to understand the load path, the boundary
Absolutely.
conditions, the element
Yes.
types, all that kind of stuff.
Oh
And
yes.
and I'm somewhat biased in this in some ways, because I'm partnered with a large software development company.
Hmm.
But pick a software that is easy to use, but does allow you to dig down into the details, So, I mean, I know there are tools which are meshless, will give you answers very quickly in a sort of black box way of looking at things.
Yes.
And there are also very, very dedicated professional tools which will allow you to dig down into all the detail, I'd probably suggest going somewhere in the middle.
Yeah.
So a tool that gives you the visibility, but you don't spend hours, days, or weeks learning the workflow, and there are tools available that are set up in this way now that you can balance that ease of use with that fidelity to give you the insight into the models that you're looking at, Start simple, find good supportive companies, good engineers that you can learn from, and then build up your skills in that way.
Yeah. A lot of very good advice, and I think you gave the keyword black box. Through that, FEA can be black box, but it should not. Okay, it's important. We have a solver to solve the complex equations. We don't need to enter into that. But we have to understand what happened in the background in order to make sure that we are able to interpret properly the results. The black box is good, but not too much. As you said, like meshless, it's too much black box. But for now, it's too much black box. And also, I love your point about mentoring. It's really, really important. It's a key aspect. It can boost really your learning process of FEA, because, as we said, FEA is complex. So if you can find a good mentor, it's a really, really good advantage.
Perhaps I haven't mentioned as well, of course, that the work that we're involved with. There are lots of online courses available that people can take as well, of course. To build up your knowledge. But I think you need all of these things. Good software, good training, good mentors to really develop your skills when you start.
Yeah. Thank you for that, Steff. As we know, as we said before, FEA is used to solve complex problems because it's a very, very powerful tool. But according to me, FEA is often surrounded by myth and misconceptions. Okay, I would like you share with us what are some common misunderstanding about FEA that you've come across, and how do you address and correct these misconceptions?
Yeah, okay. Well, what one of the misconceptions is something that I saw very recently, actually. I think it was a comment on a LinkedIn post, and it was somebody saying that software A was more accurate than software B. And
we see that very often.
Yeah. and I like to think of this like FEA software is a tool to do a job,
Yes.
And if you use the tool badly, you'll end up with a bad result. Yep. So it doesn't matter how, an analogy of a spanner, if you've got a really shiny, beautifully crafted spanner, if you use that spanner in the wrong way, as a hammer, for example, you're going to get bad results,
Absolutely. So, good analogy.
Yeah. So, commercial software A, commercial software B, one is better than the other or more accurate than the other. It depends on what you're doing and who's using it, So that is a misconception. I'm involved in selling software as well, So I sometimes hear people say, "Oh, product X is more accurate than product Y," and it drives me crazy. That's not really how it works.
No.
Factors that
it's wrong.
That are important here. Another misconception that I think people sometimes get hung up on is that people think sometimes that the more complex the model, the more complex the analysis, the better it is. But again, I think a good way of looking at this is to to try and use the simplest model, the simplest representation you can to try and address a problem. Okay,
Yes.
if your simple approach doesn't give you the answers you want, then you might need to increase fidelity,
Yeah.
increase the physics, blah, blah, blah. But don't assume that, just because you can create a solid mesh of all of your geometry, that's the best way to attack the problem, initially. So the misconception there would be, don't go too complex. Start simple and build your knowledge up from that simple footprint. The other thing that I often see with people who perhaps don't fully understand, the theory, the sensitivities, the building blocks that are used for developing models is a technique that people sometimes call stressing by color. So you run an analysis, you see a red hotspot, it means it's going to break at that point. Well, do you really know that that's going to be the case? Is the model refined enough to be able to believe that answer? So stress by color is a dangerous way to understand your model output. Few things there, but hopefully people will understand where I'm coming from.
It's a good sharing. So in summary, there is no better software than the other or software equivalent, and keep it simple and build the complexity from the simplicity. Yeah, very good sharing, Steff. So we are lucky in the FEA industry because we are dealing with innovation. Okay, we know that FEA continues to evolve rapidly every day. It's the beauty of this industry. Could you discuss any specific innovations or advancements in FEA that have had a significant impact on your work and the field you're working on?
Yeah. Okay. Well, I think probably the biggest thing that has come into FEA over the past few years are better user interfaces. Okay, so the maths behind FEA is always evolving. The solver technology behind FEA is always evolving. Models can run quicker. You can run bigger models. You can distribute that on much bigger compute farms and high performance compute, resources and what have you. But I think for the practicing engineer on the ground trying to do the job, the ability to build models and analyze and dissect models with simpler user interfaces, more straightforward user interfaces, I think is definitely the biggest development that I've seen in that field. Interfaces with very clear workflows, with built-in instruction, built-in help, maybe even built-in video support, where people can, how do I do this thing? I can't remember since I did it last time. Oh, there's a video. It shows me what to do. Those kinds of things, sure, you still need to know why you're doing these things, what the background is, but it gives you the workflow to be able to develop your models in a more straightforward manner, in a quicker manner, to be efficient. The other thing as well, which I probably would like to mention here as well, is in terms of innovation and development that's going on in the industry at the moment, is people talking about artificial intelligence, AI, everywhere, and there's absolutely no doubt that AI is going to help us, is helping us in many, many ways within FEA and the larger CAE and larger engineering design space. But if you think about AI being a brain that looks over your models, the analyses that you're running, one thing that I think is critically important is that if your models and your analyses are not fit for purpose, they're not developing the numbers that you want, it doesn't matter how much artificial intelligence you can wrap around that knowledge, you're never going to get the answer that you want. So it's still vitally important to have models that are, correct, verifiable. You've validated them against real scenarios to allow us to develop this AI, this concept of digital twin, to reflect the physical world. So that's something that I did want to mention as an area that is growing, but people need to fundamentally understand what's going on beneath the wrapper of that AI environment, if you like.
Well said. Absolutely. And to come back to the user interface, I like what you say. And many people are talking about the performance, but not the performance. I should not use this word. They say, "Oh, I like this FEA software. I don't like this FEA software," and most of the time it's related to the user interface. You're completely right. But okay, the solver is important, but now we are at a stage where most of the solvers are equivalent. Okay, in terms of performance and in terms of the physics they can solve. But in terms of user interfaces, there are a variety of different interfaces. So I think you were straight on the point with this step. To continue with the same, since we are in the solver / user interface topic, would like to talk about software tools, okay? Because our job depends on the software. But FEA in general relies heavily on various software tools. What specific software do you use for your FEA projects, and what do you see as their respective strengths and weaknesses? Okay, and how do these tools influence your workflow and the results?
Okay, basically. So again, big question, and it could be a big answer. I've used pretty much every commercial FEA solver you can think of.
Okay.
All the big ones and some of the little ones as well over the years. I've used lots of different pre-processes for model build and post-processes for looking at results. But my background with both the aerospace industry and I mentioned I was working with MSC Software, who are now acquired by Hexagon. My background is definitely working with MSC Nastran as the solver of choice, if you like.
Okay.
There are a number of technical reasons, but also commercial and licensing reasons why I like that environment. So traditionally, Nastran or MSC Nastran was more focused on linear FEA behavior. So whether that's linear static, so strength and stiffness prediction, stability prediction, dynamic response, frequency or time-based dynamic behaviors. But we've seen recently that with the development of some of the advanced nonlinear capabilities in MSC Nastran, so there are solution sequences now that can handle some pretty highly nonlinear problems. So the benefit there for me is that I can solve many, many different analysis types using one solver. Okay, so the solver setup, the format that's used, I'm familiar with that across the board. Okay, so that's my solver of choice. From a model build and results exploration perspective, I'm very, very heavily involved with MSC Apex. So that
a great platform.
We've talked about the benefits of UI development and efficiency and what have you. But one of the things that Apex is very strong with, if you like it, as well as being able to model quickly and efficiently, it's very, very closely tied to the Nastran solver. So there's no loss of data, no data conversion from an Apex model into a Nastran model. And equally, from the Nastran results back into the Apex environment. So there's a very strong tie up there. One of the things that I do see with some of the more legacy model build or graphical user interfaces for model build are, because they're not so focused into one solver, they lag a little bit in terms of technology. So granted, you have a UI that can build models for lots of different softwares, but they're not using the latest technology for those softwares. There's going to be a lag, So Hexagon have put a lot of work into developing Nastran, massive, but they're now effectively tying Apex into that Nastran workflow, which means that you've got this very clear workflow: build a model, solve the model, look at the results, using the latest and greatest that Nastran has to offer in a very, very smooth and slick way. So it's been somewhat of a challenge in terms of getting certain areas of the industry to look at new software platforms. Apex is having to play, I wouldn't say catch up, but it's difficult to convince some companies that even though you have a tool that's really good and really appropriate for what you're doing, getting people to switch can be quite lengthy. But I've worked with many companies who switched over to Apex and Nastran as a platform who see real benefit with that kind of workflow.
About this software topic, which tool do you think could compete with MSC Apex and for the pre and post processing side, and with Nastran for the server side?
Okay. Well, from a commercial perspective, Abacus has always been used for non-linear work, or focused more on non-linear work. So there's definitely an Abacus community for non-linear work. But from my perspective, if we can stay in the Nastran environment and then hold the full workflow from linear into non-linear without having to switch, then that's a big benefit. I obviously see a lot of companies working with ANSYS. ANSYS has a huge footprint. Maybe not so much in the aerospace industry.
Not at all. No.
But there are
the other industries,
lots of general mechanical industries that work with ANSYS. From a model build perspective, there are tools by Altair and Siemens who can build models for these different platforms. But again, they tend to be more generic and not hyper focused on one solver. So there'll always be some lag with the technology that they can support.
Absolutely.
Big market, lots of tools. I mean, one of the good things with the field that we work in is there's always new technology coming out.
Correct.
Which is very interesting to keep abreast of.
Thank you for this software sharing. But it's as I said, it's a very important aspect of finite element analysis. We cannot do without those software. So now let's talk more about the human aspect of FEA, especially the role of collaboration, because collaboration often plays a critical role in a successful FEA projects, and teamwork is often essential in complex FEA projects. How does collaboration play a role in your work, and what strategies do you use to manage and enhance the team efforts effectively?
Again, that's a really good question, and a big question. If we think specifically about the aerospace industry, there are many people working on the structure at the same time. So if I think back to, I was working with a company who was developing part of a commercial wing structure. So the full length of the wing, we had, let me think, maybe 6 or 7 companies feeding into that workflow. So probably, I don't know, maybe 100 FEA engineers involved. And, we would have people working on different pieces of structure, all working in a Nastran-centric manner. So delivering models in Nastran format that needed to be grafted together. I was lucky. I use the word lucky in inverted commas. I was lucky in that I had to assemble all of this work together. So that major headache in terms of that level of collaboration. But you have to be very prescriptive in terms of the way that people work. You have to use templates as much as you can.
Sure.
You have to use things like numbering conventions to make sure that things fit together. So, a whole host of different things that have to be managed from that collaboration perspective. And again, so I mentioned templates. Standardizing stuff as much as possible.
Absolutely.
Standardize reporting, standardize verification checks, standardize data formats, even things like solver releases, need to be standardized. But for those larger scale projects, you've really got to be, very careful the way you control the data that's coming to allow you to collaborate. I'm sure you've seen many examples of this yourself, with
sure. I have been in the same situation where I was integrating the complete aircraft using parts coming from different partners, and it's the collaboration in that case is crucial. And as you said, we need to have strong guidelines that everybody is following in order to make sure that at the end, when you assemble the final product, an aircraft, for example, you don't have conflicts or stuff like that.
One thing that perhaps we haven't mentioned is simulation data management. Which obviously, I don't know, people listening will be familiar with this, but you have product lifecycle management, which handles design data. But a subset of that is simulation data management, where you have database architectures, which can effectively bring all this stuff together, check it, make sure it's appropriate for the build that you're looking at. And those things certainly in big organizations can become a real headache. So having an efficient SDM tool in there can be.
So which SDM tool did you use in your experience?
I've let me think. There's a couple of the names escape me now. Actually, there's I think it's called Sim Manager.
Which
is a Hexagon.
In the Nastran world, it's common to use Sim Manager.
I think interestingly, Sim Manager in its early life came out of one of the German automobile companies.
I
think.
I didn't know.
So you can imagine. I don't know whether you'd say automotive was more of an early adopter of FEA than aerospace. They're probably neck and neck, but certainly from a configuration control, you need a car that has, these different requirements. Perhaps you don't get with an aircraft, so they need to handle their data in a very, very rigid manner.
Correct.
It's interesting to think that those kinds of database architectures have come from that environment. So.
Thank you for that, Steff. So, as we said before, the FEA industry evolves very, very, very fast. It's the technological advancement are very fast. So it means that staying informed is crucial for an FEA engineer. So how do you keep yourself updated with the last trends and the developments in FEA?
Okay. Well, again, big question. Running a consultancy, I don't know where my next project is going to come from. I've got lots of clients who keep coming back with similar work, but I don't know if around the corner somebody's going to want to look at a satellite system or a tank system or a bicycle system or whatever, So it's important to be aware of the kinds of things that are going on. So obviously I'm involved partnership with Hexagon. So I see a lot of technical development that's going on. So big area that's developing at the moment is electric vehicles. So battery technology, structural optimization to be able to house those batteries. So lots of development there. There's lots of development. I mean, people talk about multi-physics, where people are bringing different types of analysis together. Huge advancement in there, and also development with the physics, but also the ease in which those different types of physics can be grafted together. So in the past, it's been quite difficult to look at fluids and structures together. Now there are tools that allow this kind of stuff to develop or to be used much more easily. So a lot of work that I see coming through with Hexagon in terms of new developments. The other thing the other entity or organisation that I'm involved with is NAFEMS, who develop training, develop benchmarks, studies around new software developments. So NAFEMS are a great organisation if you're looking for reference material, understanding different domains and how they interact together. So that's definitely a great resource to look at.
Sure. Yeah, that's good. You mentioned NAFEMS.
And also, like you, Dominic, I'm involved in developing new training courses all the time. So it's useful to be able to see what's going on, where the market's moving, and have an eye on what needs to be developed to suit that evolving market.
Yeah, absolutely. Yeah, and as we mentioned before, FEA is everywhere. Everything is simulated now. So, but do you think that multi-physics will be the main topic of FEA in the future?
Possibly, but not necessarily. It goes back to what I was saying about keeping things simple.
Yeah.
There's the software companies want you to be using every technology you can think of,
Yes.
for obvious reasons.
Yes.
But again, it does go back down to: do you understand the problem? Do you understand the physics and how you can use those physics to solve the problem?
Correct.
Do you need that super exotic material model, or can you use something simple? Do you need that super or that high level nonlinear approach, or can you use something more simple? So yeah, there are obviously massive developments in the market, but it does depend on the problem, the structure, the industry that you're in.
Yes.
Where you need to be focusing your attentions in terms of developing your knowledge and understanding.
Correct. Correct.
So.
Yeah. Okay. Thank you. So to conclude with this interview, I would like to talk about the emerging trends. It's related to what we discussed before, but looking ahead, what emerging trends? We talk about AI, but there are many other trends that we see in FEA. So, are there any particular areas of innovation that you believe will shape the future of FEA?
Again, big question. I think that goes down to deep technology. High level technology advancements. Models run faster, bigger models, better computing capability. The way into that technology through the user interface, that's going to be developing. Now whether you use the interface out of the box or whether you customize the interface, so whether you need some programming skills to be able to do those kinds of things, it is important, and people can learn those things. The one thing that I've seen that is a very useful means of using AI, if you like, is in the development of what we call reduced order models. Okay. So, we can run our complex models across many different environments, load cases, constraint types, material systems, and what have you. But we can use the AI to look at that data set and give us a model that will run much more quickly, still using the same mechanics in the background, but will allow us to focus our attentions in a way that perhaps we can't do at the moment. So that means that things like digital twins will become more efficient, because we might have a Nastran model of an engine that might be looking at some kind of vibration phenomena that could take days, maybe not weeks, but certainly days to solve.
Yes.
But if we run all these models in the background, the AI can then be used to feed the digital twin almost in a real-time sense. So that we've got the ability to take that massive amount of data, that massive data set, and perform real-time calculation to feed the structure that we're looking at. So again, big topic, big, many different avenues or areas where this can help us. It's a good place to be. If you're interested in FEA, it's a good place.
Exactly. That's a good summary. So many new technologies, machine learning, AI, digital twin, high performance computing, a lot of different stuff that FEA is using, and it is the reason why we love FEA.
Yeah, it's a good place to be.
Yeah, it's a very good place, and for engineers, it's very challenging, but it drives the motivation for the daily work, definitely.
Good stuff.
Thank you very much, Steff, for sharing your thought about FEA, about your work. I'm pretty sure that the audience will appreciate what you shared with us today. I have to thank you very much for your time and for participating to this episode of FEA Journey. Thank you very much, Steff.
Thank you, Dominic. It's been a pleasure to speak with you. Thank you.
Thank you. Bye.